pre-trained TL model. So this is something like a ready-made model. You can use it for multiple tasks, isn't it? I can take this guy and I can use like model.predict without any alteration. If I call these any pre-trained model, the popular pre-trained model like VGG16, MobileNet, ResNet, AlexNet. Okay, these are all some popular pre-trained deep learning models. Model.predict. If I pass, just for an example, I'm just giving some image. Our model will say that what is the output this is going to tell me. It is going to give me the output like 1000 cross 1 vector probability score, and the label allotted for the car would get the highest probability. Assume it is like a car. It does not look like a car. Just or in the picture, if I have a cat image, the probability for the cat label will be the highest. So model.predict, if any input image I can pass, it is going to give me the classification by default. Okay, by default. In the previous session, what we have done, we did some modification, right? Output layer I changed. Output layer changed.
1 cross 1 like that.
4 cross 1.
4 cross 1.
Okay, for bounding, we used like a BBR, bounding box radius. Likewise, what else I can use it? In fact, we have used those version in our foundation course. Just I'm asking you to recollect. Okay, let me give a clue. Okay, let me give a hint. Can I use a pre-trained model? Okay, without output layer, how can I use those pre-trained models? Without output layer. Just model.predict. Model.predict. I'm passing the same car image. Same car image. This time, it is not going to give me the probability score, isn't it? Because I have removed the output layer. I have removed the output layer. So now this model is behaving as what?
Generative something, sir. Generative
Feature extractor. It depends upon whether I want the original two-dimensional feature. If I want original two-dimensional feature, I should remove the entire top layer, isn't it? Entire top layer you remove. If I remove the entire top layer, what is the output it is going to throw? The last stage of the CNN layer. Just like how we modify the architecture by tapping the last layer of the CNN layer, and then we convolved with the 4 kernels of size 4 cross 4, and we perform the convolution operation to get 1 cross 1 output, and then we reshaped it to 4 by 1 vector like this. Suppose if I wanted to have the original feature representation in 2D form, okay, I should remove the entire top layer. I can use it as a feature extractor, two-dimensional feature extractor. Suppose if I include the top layer, but I just removed only the output layer. Output layer is the layer in which we have created one hot encoded vector. Only the output layer alone, if I removed it. So the last dense layer output it is going to show us. Say for example, if it is a VGG16, what is the size of the last dense layer? The size of the last dense layer is 4096 neurons. Sir, how do you remember for all the architecture mix? No need to remember. You just refer the documentation page and you try to comprehend. You should know how to comprehend it. No need to memorize anything. Since I'm using all these, discussing all these models as part of my training, I know it. At least I know the last layer, because it's very common to extract the last layers. So obviously for the many popular architecture, I remember the size of the last layer. For example, in the previous session we used MobileNet. I know what is the size of the last CNN layer. The last CNN layer, it is going to give us 4x4 size. Again, if you talk about what is the last dense layer of MobileNet model, it is going to give us, I think it is 1024 neurons, I guess, but I'm not sure. Always we have the block diagram, we can refer to the documentation, but I'm sure about VGG16 last dense layer, it is going to have 4096 neurons. What is the difference between this 2D feature and this 4096? Can you able to make a difference? What is the difference between tapping this result or tapping this result? They are original feature, isn't it? They are original edge features. Obviously, edge, color, texture features. But what about this? They are transformed features. So why I'm saying it's a transformed features? Because this feature has got flattened, okay, and applied to various dense layer, and finally you got the last dense layer, isn't it? Obviously, your feature got transformed through various hidden layer. Why it got transformed to various hidden layer? How do you answer this? Look at the chain of question. See, this is how the interviewer will take the chain of question from your answer. What is the first question they ask? Interviewer asks, what is the difference between accessing the last CNN layer and accessing the last dense layer? What did you answer? You answered the last CNN layer is the original feature representation, two-dimensional format. What is this last dense layer 4096? It's the transformed feature. Then the next question the interviewer may ask, okay, why it is the transformed feature? Why your features are getting transformed? What is the reason? That is the fundamental answer is what? That is the purpose of the multi-layer neural network model. Fundamental goal of any multi-layer neural network model. How you can answer? The raw representation, if I have only the raw representation of the feature representation, they are not linearly, they may not linearly separable, isn't it? Obviously, because of the non-linearity only, we are introducing the dense layer, right? What is the why we introduce the dense layer? If this feature itself it is linearly separable, I could have directly connected, just flatten it and connected the output layer, and I can say, okay, for the dog, okay, this is the two-dimensional features of the dog. Let me flatten it. Okay, let me flatten it, and output side I have 3 nodes. Okay, this is the probability for the dog, 100% probability for the dog, a cat, and a rabbit. Assume only 3 objects, 3 classes I wanted to classify. Whenever I feed a cat, it is going to give me the two-dimensional features of the cat. Let me flatten it. But just by looking at the feature, I should train my model to learn 100% probability for the cat. Whenever I throw a rabbit picture, get the two-dimensional feature, flatten it, and I can train my output layer. Of course, after flattening, it has certain number of features. Say, for example, the size of the last CNN layer is something like, say, some 100 dimension, assume some 100 dimension. So it is like 100 features, flattened features. So output 3. So 100 into 3, 300. So 303 weights, just by using 303 weights, including 3 bias. Just by using 303 weights, I can easily classify the features of dog or cat or rabbit. Why I introduce the dense layer? Since these features are not linearly separable, so I introduce dense layer to transform these features as a linear combination of the features. You introduce many hidden layers. It is represented as the transformed features. After transforming your features to few dense layer, then finally your output layer could recognize the features, could able to separate these classes, without much overlapping. So your score improves in terms of precision and recall wise. Your score improves with less overlapping. Otherwise, without using the dense layer, your model is getting confused between cat and rabbit. Sometimes it gets confused between dog and cat. Your precision recall is very poor, around 50% or 60%. The reason is your features are highly challenging to differentiate. That is why we introduced the dense layer. You understood the difference. Tapping the feature at the two-dimensional, the last stage of the two-dimensional level is the raw representation of the feature. At the same time, tapping the last dense layer, which is equivalent to transformed representation of the feature. Why transformed representation of the feature? Finally, because the features may be linearly non-separable. That's the reason we may introduce the hidden layer. And the transformed features was easy to separate. But most of the pre-trained model, there were 1,000 classes, not even 3 classes. Imagine for 1,000 classes, your features should not overlap. Only the transformed features are less overlapping. That is the reason we were able to recognize the object with high level of precision and recall. Are you clear? So what is the third role? I can utilize the pre-trained model as a feature extractor. So all 3 operations, you can use it even without training. And also, what is the partial training and all the other stuffs, even for the previous case also, we have set 2 mode, lab 1 exercise. Okay, true option, false option. Create model with the true option, false model. True means you wanted to train the entire CNN layer, right? If you put a false, that means only the output layer alone, only this fully connected layer alone, whatever the newly designed layer alone, is going to update the weight. Of course, by compromising the score. Okay, the full network, if you train, you may reach the IOC score around 65 to 70%. If you train only the last portion, what you have designed, you may get around 60 to 65%. 60 to 65%. The full architecture 65 to 7. So that is the difference you will see. So these foundations you should be thorough at any cost. Don't ever forget, okay, or don't ever get confused with.